Triangle similarity theorems. So we talked about how to tell if two figures are similar. Well, these are going to provide us with shortcuts to see if two triangles are similar. First one is angle-angle, or AA. If two pairs of corresponding angles are congruent, then the triangles are congruent. Side angle side, or SAS. If two sides in one triangle are in the same proportion to the corresponding sides in the other, and the included angles are equal, then the triangles are similar. Side, 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 or SSS. If the lengths of the corresponding sides of two triangles are proportional, the triangles are similar. All right, so let's move into our examples. All right, so example 1, we're going to state if the triangles in each pair are similar, and if so, we're going to state the triangle similarity theorem and complete the similarity statement. All right, so when we take a look here, we see that we have no angles to deal with, so we know that it's probably going to be side, side, side. That's what we're going to be checking for. So in order to do that, we need to check to see that the three sides are proportional. So we're going to go as normal and number them numerically. 1, 2, 3. 1, 2, 3. We need to establish which one is our old figure and which one is our new figure, and it does not matter. Okay, and now we need to set up our fractions. All right, so the first one is 42 over 49. 66 over 77, and then 78 over 91. All right, so when we do our division, we get 0.857, 0.857 for this one as well, and then again 0.857. So since all three sides are proportional, that tells us that yes, it is SSS similarity. And please make sure that you write the word similarity at the end, because we also have a congruence theorem with this same name. We don't want to confuse the two. So make sure you write SSS similarity. So now we need to take a look at our similarity statement. So we have TUV, okay? So we're going from T to U to V. So we're traveling along the 2 side to the 1 side. Okay, so we're gonna have to duplicate that here. So we're traveling along the 2 side to the 1 side. Does everybody see that? 2, 1, 2, 1. So that's gonna be FGH. All right. Example 2. So right off the bat, we see that we have two congruent angles. So 41 equals 41 and 83 equals 83. Well, that's simple because we know that that is angle-angle similarity. All right, so let's go ahead and name it. So this one is named QRS. So we're going from angle 2 to angle 1. So QRS. So we do the same thing here, 2 to 1. UVW. All right, and our last example, example 3. So with this one, we have one triangle inside of another triangle. Does everybody see that? So this is one triangle, and then this is the other triangle. Now, it is my suggestion that the first thing you do be to split these triangles up. So I'm going to go ahead and kind of redraw. So this is BVU. This is very important. Do not skip this step. And this is BCD. And now we just need to write in the values for each of these triangles. So let's take a look at our original figure. So we see that BV is 9. So I'm just going to write that over here. Okay. Now with this 66, we see that BC, do we see that? The whole length, BC is 66. So I'm going to find my BC. BC is 66. Now we need to see what else we can find. We don't have an angle measure for either of the bottoms, Let's see if we can figure out what this side is, BU. So how would we figure out what BU equals? If the entire side is 66, part of the side is 55, then that means that in order to figure this out, we would have to do 66 minus 55. Does that make sense to everyone? And then that will give us 11. Now we're going to kind of do the opposite to find the length for BD. So we see the length for BD is this entire side here. So how would we figure out the length of BD? Well, we would have to add together the 45 and the 9. So 45 plus 9 will give us our Y. And when we add those together, we get 54. Okay? So there's one last thing that I noticed. We all see that when the triangles are in their original figure, they share angle B. So that means that these angles are congruent. So right now with what we're looking at, we know that this can possibly be side, angle, side, possibly. But in order for that to be true, we need to check to see that our side lengths are proportional. So let's just do numerical value, 1, 2, 1, 2. All right, so if we make this our original and our new, for the 1s, that will be 54 over 9. And for the 2s, that will be 66 over 11. 54 divided by 9 is 6. And 66 divided by 11 is also 6. So that tells us that these sides are proportional. So if we have two proportional sides and we have a congruent angle, then our answer is side, angle, side, similarity. Again, you must write the word similarity because we also have a congruence theorem that is SAS. All right, so now we need to do our similarity statement. So we have BCD, so that's BCD, BCD, and so that is just BUV.